Now I want to talk about how data is collected in the laboratory quickly and accurately with Study Advantage. Study Advantage supports almost all types of laboratory instruments. Here's a few types. Here's a picture of an electronic balance, and you can see there's a input for a data cable right here. There's calipers, electronic calipers also connected with the data cable to the computer in the laboratory. There's foot pedals for hands-free data entry. And there's many other types of devices that Study Advantage supports, including chip readers, imaging devices, just about any type of device you can imagine. So let's go ahead and show how data is gathered in the laboratory by the technician. So I'm going to depress a foot pedal, and you can see the cursor is blinking in a dimension field, tumor length. By depressing another foot pedal, Study Advantage automatically reads from the calipers because it's in a dimension, a tumor dimension field. And by depressing the foot pedals further, we get body weight measurement. Comments can also be added, some that the study director has defined, or free format, just like that. And then data can be saved to the local database in the laboratory, and when there's connectivity to the central database or at the technician's desire, the data can then be sent up to the server. But before I do that, I was just going to show you the verification function. And I'm going to click the Verify button to manually verify that the data is good. Well, what does that mean, that the data is good? The study director has defined certain parameters saying what the maximum tumor length and body weight can be, ones that make sense. Let me give you an example on a different animal. For example, I'm just going to keyboard in a gigantic tumor volume here. When I try to do that, I see a pop-up alert, audible and visual, that says the measurement is too small or large. Please re-enter. And now the technician with the animal in hand can redo the measurement. So we want to ensure accuracy right on the spot. Also, if you try to do a verification here, and I'm going to collapse the grid just so you can get a better look, you can see that this is flagged in red and it's not verified because a valid tumor volume or body weight has not been entered. So I wanted to show you that. So that's very important for accurate data entry, and that's a good thing. So we've saved that one measurement, and I want to show you that scientists and the study director in real time can see the data coming in from the laboratory. This is a chart, a study phase chart that the study director might be looking at. Now, in real time, we're going to send the data up to the central database, just like this. And the technician is required to do a network login. That only happens once, by the way. And we have success, transfer complete. That data has been sent up to the central database. You'll notice a body weight alert came in. A body weight alert came in because, let me show you that, because of a precipitous drop in body weight according to parameters that the study director has defined. That's the subject of another video which you might want to look at. The video is entitled Ethical Alerts. Anyway, what does the study director see? Well, let's refresh this chart to show the new data that's come in from the laboratory. So there you can see that new data point has come in, and you can even look at it on another chart which shows specific measurements within that particular group. So these charts are updated in real time. You could also look at that data another way as the study director or scientist using Internet Explorer once again. And here the body weight alert has also been reported to the study director. You can see that the measurement coming in from the laboratory has been stamped with the date and time, and has also been stamped with the name of the technician who took the measurement. This is a GLP-like convention. You can also see the comments that have come in from the laboratory. So that's how data is taken in from the laboratory. Another thing I wanted to show you briefly is drug administration. So let's take a look at that. Here's the drug administration schedule as the study director would see it. And since body weight was taken only for this one animal, dosing based on body weight is computed. Now in the laboratory, the technician can also look at that self-same drug administration schedule. And that's for a particular day. So I'm going to expand the schedule, and as the technician doses the animal, they might check off that the dosing has been completed. Here again you can see dosing based on body weight. So I'm going to check off that animals have been dosed as they've been dosed. This is just one example. And now I'm going to save that and send it up to the central database. You notice I didn't have to re-enter the network password this time. Now the study director wants to take a look and see what's going on in the laboratory. So we're going to refresh this screen. And the study director is going to take a look. And the study director can see which animals have been dosed because of the check mark. The study director might also look at the pending animals screen, meaning these are the animals for which dosing is still pending. So if it's 5 o'clock and there are still animals in this list, the study director might want to get in touch with the laboratory technician and say, hey, what's going on? How come the dosing isn't complete? So that's a brief high-level overview of how data is accurately and quickly acquired in the laboratory and how the study director can share that data in real time.